Hello, my name is Amy Imdek. I'm a recent graduate from St. Olaf College and I studied chemistry and English. Welcome to the Cryosphere Pavilion. This event is Arctic Climate and Health Implications of Short-Lived Climate Forcers. I want to welcome those of you who are watching virtually, including our Cryosphere Pavilion hubs in Geneva and Stockholm. You'll have the chance to post questions into the chat, or for some of you at the hubs, directly to the speakers during the question and answer period. I would now like to turn it over to Rolf Rovden from AMAP.
Thank you, Amy. Good afternoon, everyone, both those of you sitting here, as well as our virtual presenters, and also to the hubs we have around, also up in Tromsø, where I'm usually located. I'm very happy to see you here at the session on Arctic climate and health implications of short climate forces. This is a joint session between the two working groups of Arctic Council, the Arctic Monitoring Assessment Program, or AMAP, as I represent, as well as ACAP, the Arctic Contaminants Action Program. In this session, we are now going to have 5 introductory talks by some of the experts that have contributed to the AMAP short-lived climate forces assessment. Thereafter, there will be a panel discussion. And after that, again, Lasse Bjørn from the Sami Council and ACAP will introduce 2 of the ACAP films on short-lived climate forces. So, and I hope that the panel debate will be an open debate and you're all invited to contribute with questions. So to start with, I would like to introduce our AMAP chair, Ben Dangelo. His representative is the AMAP representative, and he's usually located at NOAA in US. So please, Ben, would you like to introduce the session and the AMAP assessment?
Thank you, Rolf, and I hope my sound is okay. Hello, everyone. As Rolf said, I'm Ben Dangelo. I'm the chair of AMAP, the Arctic Monitoring and Assessment Program working group, and my host institution, again, is NOAA, National Oceanic and Atmospheric Administration in the United States, where I also serve as the deputy director of the Climate Program Office. AMAP is one of 6 working groups under the Arctic Council. The Arctic Council is a collaborative forum of 8 nations with Arctic territory: Canada, Denmark, Iceland, Finland, Norway, Sweden, the Russian Federation, and the United States. And it includes the Arctic indigenous peoples, represented by 6 permanent participants. It's the 25th anniversary of the Arctic Council and 30th anniversary of AMAP. In its most recent Reykjavik Ministerial Declaration of 2021, the Arctic Council was instructed to, quote, continue to advance its work on monitoring and assessments on climate change impacts, adaptation and mitigation in the Arctic, and to inform and contribute to the assessments of IPCC and other relevant forums to motivate stronger global action to mitigate emissions of greenhouse gases and short-lived climate forcers, and to prevent biodiversity loss, end quote. The working group AMAP was established in 1991 to monitor and assess the Arctic with respect to pollution and climate change. Around the same time, the first IPCC report projected that the Arctic would warm faster than the rest of the world. Now, AMAP's recent work documents that the Arctic is indeed now warming at a pace 3 times faster than the global average. So AMAP reports to the Arctic Council and provides independent, science-based knowledge reports to support policymaking. Over the years, AMAP has helped communicate key messages about our rapidly changing Arctic and its implications to a broader audience within Arctic countries and beyond. AMAP operates similarly to IPCC, but on a smaller scale. We assess the available literature, conduct external peer review, and our summaries for policymakers are carefully reviewed and approved by national representatives of the 8 Arctic nations and by representatives of the indigenous permanent participants. This COP26 side event is based on findings from one of AMAP's 6 recent reports completed this year: impacts on short-lived climate forcers on Arctic climate, air quality, and human health. Other recent AMAP reports address climate change trends and impacts, which will be the subject of a side event later today, the effects of climate change on environmental contaminants, including mercury and persistent organic pollutants, or POPs, pollution impacts on human health in the Arctic, with a focus on indigenous peoples, as well as our first report on monitoring plastics in the Arctic. The summaries of these reports can now be found at amap.no. So I'm thankful for this opportunity to present AMAP findings to the COP26 audience. You'll hear from our experts about the unique role that short-lived climate forcers like methane and black carbon play in the Arctic, the importance of reducing these emissions, and how a short-lived climate forcer reduction strategy can complement and contribute to the goals of the Paris Agreement. I want to thank our host for this event at the Cryosphere Pavilion, ICCI, and I'll now turn it back over to Rolf, our AMAP Executive Secretary, who of course is there with you at COP26 in person. Thank you.
Knute is a research scientist at the Canadian Centre of Climate Modeling and Analysis, Environment and Climate Change Canada, and an adjunct professor in the School of Earth and Ocean Sciences at the University of Victoria, Canada. Knute also co-led the AMAP Short-Lived Climate Forces Assessment chapter, as was mentioned by Ben. Concerned with modeling in the Arctic climate impacts of short-lived climate forces and co-emitted air pollutants. And Knute will here talk about the AMAP short-lived climate forces assessment, in particular on climate implications of short-lived climate forces. So, Knute, please go ahead.
Yes, hello everybody, and thank you, Rolf, for the introduction. So the sustained warming of the Arctic and the loss of Arctic sea ice are hallmarks of climate change. While global climate change has been mainly driven by carbon dioxide, many air pollutants act as so-called short-lived climate forces that can significantly affect Arctic climate. So in the following, I'm going to primarily address how particulate matter pollution affects Arctic climate, but I will also talk about methane. Many studies and our assessment consistently show that clean air policies are essential for reducing particulate matter pollution and improving human health. Dr. Annenberg will provide an assessment of health impacts after my presentation. But clean air and particulate matter policies also have important consequences for Arctic climate and the goals of the Paris Agreement. Particulate matter consists of matter that warms and cools the climate. Can be transported to the atmosphere to Greenland, where it deposits on ice and snow. Once the warming component, black carbon particulate matter, has settled on the snow, it can reduce the brightness of the snow. Snow and ice impurities can be very noticeable during the Western Greenland warm season, as the photo shows. Although our scientific understanding of the physical and biological causes of these impurities is still evolving, there is a scientific consensus that black carbon contributes to snow impurities. It thereby darkens and warms the snow and ice throughout large regions of the Arctic. The IPCC Working Group 1 is using the shared socioeconomic pathway scenarios for climate projections. These SSP scenarios capture a wide range of possible future greenhouse gas emissions. And you can see those full lines here on the graph. In addition to the SSP scenarios, we also use a dedicated set of scenarios focused on specifically on the mitigation of particulate matter and other air pollutants. These are indicated by dashed lines in the figure. Emissions of key particulate matter species are projected to decline globally in nearly all of the available scenarios. So this doesn't matter if it's an SSP scenario or one of the dedicated scenarios. The scenarios are particularly the reductions are particularly strong in the sustainability scenario, which is SSP 1 to 6. And so this scenario has strong greenhouse gas and air quality mitigation objectives. So keep that in mind. The IPCC Working Group 1 determined that there's high confidence that the Arctic will continue to warm above 2 times the rate of global warming. Our own best estimate is that the Arctic temperature could increase by 2 to 3 degrees Celsius between present and 2050 in the SSP scenarios. So this is in addition to the warming of about 2 degrees Celsius over the historical time period. But the exact magnitude of the warming is uncertain due to the large natural variability of Arctic climate and climate model uncertainties. We also find that carbon dioxide and sulfate particulate matter could contribute equally to the Arctic warming. And this is especially the case in the sustainability scenario, the first one that you can see on the left. So if you compare the orange with the blue area, this gives you the comparison between sulfate and carbon dioxide impacts on Arctic temperatures. So let me explain this. Sulfate particulate matter, which is produced from sulfur emissions, cools the Earth's surface by reflecting shortwave radiation and enhancing the cloud albedo. And this has masked some of the Arctic warming in the past. With globally declining levels of sulfate particulate matter, the masking of global warming is diminishing, and this enhances the warming globally and in the Arctic. Sulfate particulate matter is regulated through clean air policies, and these policies will generally affect how quickly the Paris Agreement goals can be achieved. So we further analyzed 2 of the dedicated scenarios that I mentioned in the beginning, and these were specifically designed to assess changes in particulate matter and air pollution. So they're a little bit different from the SSP scenarios in some ways, and I'll explain that. So the current legislation scenario, CLE, assumes full implementation of current clean air policies, as well as commitments under the Paris Agreement. The speed of global emission reductions in this scenario is comparable to the middle-of-the-road SSP2 scenario. And the maximum technically feasible reduction scenario, MFR, assumes the adoption of best available technologies for all air pollutants and methane without any constraints related to investment costs. This produces deeper global emissions reductions than any of the SSP scenarios that we have considered, and they are also faster. So the figure on the left shows the Arctic temperature difference in 2050 between these 2 scenarios. Strong global black carbon particulate matter and methane reductions could slow Arctic warming by about 0.5 degrees Celsius. And they contribute about equally. Black carbon seems to be a little bit stronger in our analysis. So this would largely mitigate the unmasking of Arctic warming from sulfur emission reductions. And the brightening of the snow from reduced deposition of black carbon particulate matter could cool the Arctic by about 0.2 degrees Celsius. And so this is a substantial portion of the temperature difference between these scenarios. Black carbon particulate matter emissions from Arctic Council countries are more efficient at affecting Arctic warming than global emissions. And so this really supports the need for regional policies. Globally, warming could be reduced by about 0.2 degrees Celsius. So let me conclude, and I can happily explain details later during the questions. So overall, we conclude that particulate matter pollution is declining globally with declining fossil fuel use and the introduction of clean air policies. Regardless of air quality improvements, the enhancement of Arctic warming from the declining sulfate component of particulate matter could be considerable, and it may even be comparable to the warming induced by carbon dioxide emissions in the near term. So it will be essential to develop comprehensive policies that further reduce the black carbon component of particulate matter and methane over the next few years. Regional emission reductions can be efficient at producing both local air quality improvements and Arctic climate benefits. Well, thank you very much.
Climate change in the Arctic, both by increasing and decreasing albedo, as well as the absorption of heat. Our next talker, our next speaker is Jessica McCarthy. Dr. Jessica McCarthy is an assistant professor of geography and a director of the Geospatial Analysis Center at Miami University, Ohio, USA. Dr. McCarthy is an expert on fire remote sensing, and she led the AMAP Shortly Climate Forces assessment chapter concerned with climate change and changing Arctic wildfire regimes. And Jessica will have a talk about Arctic wildfire, the wildfire regimes, and what we can expect in a warming Arctic. So Jessica.
Thank you very much, Ralph. And hi everybody, I'm Jessica McCarty and I'm an associate professor of geography. And I want to acknowledge all the members of the AMAP SLCF expert group, as well as my co-authors on our related paper deriving from the Arctic fires chapter. When we talk about Arctic fire emissions and fire regimes, it's important to understand this is a context, a sliding scale, where we're thinking about changes in total ignitions, often represented as this flame triangle across both landscape, space, and time. Individual fires can be seconds to hours. We think about fire behavior across days, where we start to consider weather, fuel, and topography. And then the fire regime is often regions like the Pan-Arctic, where climate and vegetation changes, land use and land cover change, and ignitions, of course, are very important. Fire emissions in this context of a changing Arctic are really then on timescales of days to months, often reported in our emission models and official emission inventories by months and years. And we think more about the quantity, the rate of the emissions, the impact on the air quality for the people who live in the boreal and the Arctic. And of course, what's really important for black carbon is often the transport itself. Based on more than 200 peer-reviewed published articles, we found that overall, we expect an increase in future Arctic fire risk and fire regimes by the mid to late 21st century under RCP 4.5 and RCP 6 and RCP 8.5. So basically just an increase. If we think about first, in North America, we see this as increased lightning, a transition from boreal forest to grasslands, expansion of agriculture north, and of course, a boreal tundra zone where there is peat drying and becoming available ground fuels. We do note that there is a decrease in fire risk as coniferous to deciduous transition occurs in much of eastern Canada. And this, of course, is also noted throughout Northern Europe and the Nordic countries. In Europe and across Eurasia, we see a similar, almost a mirror image to what we expect in North America, where their boreal tundra zone will transition to a dry peat, increasing available fuels. Agriculture expands north. This is already being documented throughout much of Western Siberia. A forest step-to-step ecosystem transition, which would just increase the amount of fires and thus the amount of smoke. Tundra to taiga transition, and a taiga to permafrost thaw, which would pause fire risk momentarily, but then as the transition completes to dry peat would increase fire risk. So overall, we have this pan-Arctic increase of fire risk and likelihood of fire emissions and smoke. Extreme fire years like 2020, as we can see here, plotted in red from the GFAS wildfire emissions system outpace anthropogenic sources of black carbon originating within the Pan-Arctic. The darker colors are north of 65 degrees, and the lighter colors are north of 60 degrees. And by 2015 and 2020, we're seeing that fires are much higher than even flaring. So this is an increase in long-term wildfire emissions as noted by our satellite models. We're also seeing a transition in the fire season itself. Throughout the Sakha Republic, a 13-day longer fire season started a decade ago, where there's an earlier start to fire seasons as soon as April, with the peak of fire occurrence earlier in May, June, July, which is important for potential transport of black carbon across or up to Arctic sea ice. In these images, we can see from ESA Sentinel-2 satellite that by the end of May, wildfires 70 degrees north were burning on the shores of still frozen thermokarst lakes and continuing to burn well into October. This 2021 fire season was also a very similarly an extreme year, both in Eurasia and then parts of North America. This is shared from Environment and Climate Change Canada from the 5th of October of this year, where you can see, well, Western wildfires throughout the US are producing quite a lot of smoke and PM2.5 pollution, but so are late season fires in Alberta, Manitoba, and Saskatchewan, which are creating fire and smoke, or creating smoke transport across the lower Hudson Bay and well into parts of the Arctic Circle. So how do we prepare and predict for the future? Well, we need to first understand that our modeling has some uncertainties that are able to be addressed if we focus our efforts. We need to consider the uncertainties in emission models and inventories, improve Pan-Arctic and Pan-Boreal fire behavior modeling and processes, as well as atmospheric processes within some of the models that Knute was speaking to previously. Temperature is important in the future, but just increased temperature won't mean increased extreme fire seasons. Fuels, ignitions are important. So there's a need for robust and dynamic future fire scenarios that include human, climate, and landscape nexus. And as we can see from this MODIS imagery on the right, that includes thinking about some of our urban and rural populations. This is the Sakha Republic from this year, and Yakutia and Yakutsk experienced many, many days, a season of smoke. So this impairs air quality as well. What can be managed? Well, we can't control lightning strikes. So we can think about fuels, but this gets complicated in the Arctic, where peat and permafrost thaw may lead to increased fuel condition and just fuels to burn. People are important, particularly with an emphasis on indigenous and local leadership and the Pan-Arctic. We have to address that human activities are often ignition sources for uncontrollable and uncontrolled wildfires. This means timber, energy extraction, and even tourism need to be accounted for as ignition sources, and these types of ignitions reduced or prevented. Cultural and indigenous prescribed burning will be important for ecological functioning and will need to be integrated into fire-wise fire management to prevent these extreme wildfires. Zombie fires or holdover fires, which I know will be addressed later on in this cryosphere pavilion, really link last year's fire season with this year's fire season, creating a complicated understanding of fire emissions and potential fire pollution from these underground burning of peat deposits. And finally, Arctic wildland firefighting policy and infrastructure it is an opportunity for international collaboration and innovation, as we will not be able to copy and paste what has been successful in our more southern latitudes and even the boreal to some of these fragile northern landscapes.
Thank you so much, Jessica, for this very interesting explanation of the scientific background underlying some of those patterns to be seen in wildfires and wildfires regimes lately, as well as pointing out some of the management options when it comes to preventing such events in the future. We're now moving over from effects on ecosystems to the people living in the ecosystem. So our next our next speaker, Dr. Susan Annenberg, is an associate professor of environmental and occupational health and of global health at the George Washington University Milken Institute School of Public Health. And she's also the director of the GW Climate and Health Institute. Susan co-led the AMAP short-lived climate forces assessment chapter concerning with human health impacts of short-lived climate forces. That's, of course, also the topic of her talk here today on human health implications of short-lived climate forces. So, Susan, please, the stage is yours.
Thank you very much, and good morning, good afternoon, good evening, good day from Washington, D.C. It is my pleasure to be joining you today talking about air pollution and health in Arctic Council member and observer countries. I want to start by thanking the many people around the world who have contributed to the work that I will share with you today, including all of the contributors to the 2021 AMAP Short-Lived Climate Forcer Assessment. So just to start with a bit of background, that climate change and air quality policy are intrinsically linked. Climate change and air pollution come from the same sources. Anytime we burn fossil fuels or biofuels, we are releasing both greenhouse gases and air pollutants. And so they share common sources and share common mitigation approaches. Climate change can also contribute to worsening of air pollution by contributing to the wildfire smoke that we just heard about, as well as dust storms and biogenic volatile organic compounds, making it easier to form air pollutants in the atmosphere. And of course, air pollutants can contribute to climate change, and that's the subject of this assessment on short-lived climate forcers. Ambient air pollution is considered the fourth leading risk factor globally. That is not the fourth leading environmental health risk factor. That is the fourth leading overall risk factor affecting global public health. It continues to be among the 10 leading risk factors for premature mortality in Arctic Council member and observer countries. And you can see this pyramid of effects from air pollution on the right-hand side here and seeing a real range of health outcomes that are associated with air pollution, all the way from lung function decrements and cardiac effects, things that you may not seek medical care for, all the way to premature mortality. Fine particulate matter, or PM2.5, is linked with cardiovascular and respiratory diseases and premature mortality. And there's growing evidence for links with diabetes and premature births and low birth weight, among other health outcomes. Ozone is associated with respiratory mortality and may also be associated with other adverse health outcomes, including metabolic effects. We can improve Arctic air pollution and health by reducing emissions from both local sources as well as pollution coming from long-range transboundary air pollution. And those local sources include residential heating, waste burning, diesel generators, surface transport, shipping, wildland fire, and of course, there's a major contribution from emissions that are released in the very populated mid-latitudes. As part of the AMAP Short-Lived Climate Forcer report, we modeled several scenarios that Knute has already mentioned, including a current legislation, or CLE scenario, and a maximum feasible reduction, or MFR scenario. And these are the simulated PM2.5 concentrations resulting from those scenarios in 2030 and in 2050 compared with 2015. And I'm showing three geographies here: global on the left, Arctic Council countries in the middle, and then Asian observers on the right. And we've superimposed upon this the World Health Organization air quality guideline for annual average PM2.5, where the thick line indicates the guideline from 2005, which is 10 micrograms per meter cubed. And that guideline was just revised a couple weeks ago. And the 2021 guideline is now 5 micrograms per meter cubed. And so just focusing on Arctic Council countries in the middle here, we see that from 2015 to 2030 and 2050 under current legislation, we see a decline in PM2.5 concentrations, but it doesn't get us all the way to below the World Health Organization 2021 guideline. Following the maximum feasible reduction scenario, we do actually get below that 5 microgram per meter cube 2021 guideline among Arctic Council countries on average. But when we look at the global average as well as the average across Asian observers, we see a different picture here where PM2.5 concentrations are not much changed in 2030 and 2050 under current legislation compared with 2015. They do go down substantially under maximum feasible reductions, but not enough to make it down to the levels of either the 2005 guideline or the 2021 guideline. What does this mean for PM2.5 mortality? We actually see that despite relatively constant PM2.5 concentrations in the current legislation scenario, that global PM2.5 mortality is actually estimated to increase by 38% from 2015 to 2050. And that is because we have a growing and aging population that becomes more vulnerable to the same concentration of PM2.5. And that increase is particularly large in Asian observer countries. And PM2.5 mortality actually slightly decreases under current legislation in Arctic Council countries. Now, when we look at maximum feasible reductions, we see that PM2.5 mortality in 2050 is far reduced among Arctic Council countries and slightly reduced globally and among Asian observers. Let's transition now to talking about ozone concentrations. We see that for ozone, there's a slight rise in 2030 and 2050 under the current legislation. And that's true for the global situation, Arctic Council countries, and Asian observers. And then we see a dramatic decline under maximum feasible reductions. For ozone-related mortality, we see that along with ozone concentrations, we expect an ozone mortality impact to rise under current legislation in 2030 and further in 2050 compared with 2015 globally. And again, that's the combination of the slight rise in ozone concentrations along with growing and aging population. And that change is consistent across both Arctic Council and Asian observer countries. As for PM2.5, we see that ozone concentrations and mortality are lower under maximum feasible reductions compared with current legislation. So I want to leave you with 3 key points to take away from this work. Number 1 is that ambient air pollution continues to be among the 10 leading risk factors for premature death in both Arctic Council member and observer countries. It's the 4th leading overall risk factor affecting global public health. We also have found that implementing actions that reduce short-lived climate pollutants would reduce both PM2.5 and ozone, the dominant contributors to the air pollution disease burden, along with attributable premature mortality. And finally, that achieving the 2021 World Health Organization air quality guidelines requires an integrated approach, addressing air quality, development, and climate policy. And that includes a major shift away from fossil fuels, as well as behavioral changes, things like shifting to healthier diets. And we found that in Arctic Council nations, on average, we can achieve the guidelines with further air quality policies and technological emission reductions, but that will not be enough in observer countries. Even maximum feasible emission reductions don't reduce concentrations to below the guidelines in observer countries, and therefore further development and climate policies are needed to move towards that target. Thank you very much. I'm looking forward to the discussion.
Thank you so much, Susan. It's really impressive. We're actually kind of scared to see the impacts it makes on societies and premature death and so on. So it's thank you so much for putting this into a societal perspective. Our last introductory talk is made by Professor Mikael Hilden. He's a professor in the climate change program at the Finnish Environment Institute. And he's also the previous chair of the Arctic Council Experts Group on black carbon and methane. And of course, due to his role, also collaborator and contributor to AMAP's work on short-lived climate forces. And Mikael, we're here to talk about policy implications of the AMAP short-lived climate forces assessment. So, Mikael, please.
Okay. This is a short comment on the policy implications of the AMAP assessment findings, and I want to acknowledge the EU-funded action on black carbon and my colleagues Stefan Åström and Bradley Matthews, with whom we did a lot of the underlying policy work. I think the presentations we've just heard show very clearly that the emissions of short-lived climate forces is a complex matter, and reducing them requires collaboration and in order to achieve the progress that can be documented. We can say that there are two main areas of achieving this. It's the policy push that, of course, started with the Arctic Council here, setting the reduction goal at the 25 to 33%, but then supported, of course, by national governments, even local governments, the EU, and then international organizations such as the IMO and the conventions, including the UN Easy Air Convention, and then, of course, as an overall umbrella, the UNFCCC. But in addition to these policy actors, we see expert knowledge, funding, and the policy debate as crucial for achieving the reductions. So we have a host of different types of organization, from the OECD to the World Bank to NGOs, the coalitions on clean air and climate, and research organizations. And the combined effort is what has contributed to the decline. And then we can say that we also find that the emissions of especially black carbon emission reductions are on track. So the collective voluntary commitment to reduce carbon emissions is readily achievable under the current legislation scenario. And that means, of course, that there are also significant further emission reduction potentials. The key to emission reductions of the short-lived climate forces is a continuation of the collaborative and joint actions. And what does this mean? It means, of course, that there is a need for the parallel and joint implementation of the agreed policies and regulations. That should also imply then allocation of funding for specific regional pilot and demonstration activities, eventually contributing to upscaling, and so what we normally call innovations that really change society. And then in order to know where we are going, we need strengthening and standardizing of monitoring. With all these in place, we can ensure that there's a regular evaluation and revision of the actual actions taken, and also a regular evaluation and revision of policies and regulations. Because as the previous speakers have shown, it is indeed a complex matter. It's not just one policy, it's a set of different policy areas with different policy actors. And then finally, as also was noted in the introduction, that it's not enough to just reduce short-lived forces. But so what are the policy conclusions on the assessment? I think the complexity of short-lived climate forces is evident. Further reductions require really societal, technical, and even cultural transitions in the key emitting sectors. And in order to achieve these, we need more systematic evaluations of actions, in particular how to understand the successful actions in difficult areas, such as the example of wildfires and agricultural burning. And maybe also to reflect on the possibility to introduce another aspirational goal for methane in a similar way to the black carbon goal that clearly has highlighted the specific actions that are needed and have achieved to date results, but still highlight also where further actions can be taken. With that, I conclude. Thank you.
Thank you so much, Mikael, for drawing up the policy landscape for us here and showing one of the success stories actually of the Arctic Council, the reduction of black carbon due to an agreement on policies. During the last talk, I also saw Kalle Kopi enter the the panel, and he's also been a contributor to AMAP's work and to EGPCM and ACAP's work. So I hope we can have you here joining the next part of this session, which is the panel discussion. But first, before doing so, I would just like to say to those of you present that those introductory talks, they refer to results from the AMAP short-lived climate forces assessment, and you can actually find a copy of the summary for policymakers just around the corner here, free for you to take. So, and it's also downloadable at www.amap.no. So then I would like to move into the panel discussion, and I would also like to open the floor for questions from the audience, also here as well as at the hubs. So, but I guess as an introductory question, and I guess maybe Knute, this goes maybe to you. As you presented today, short-lived climate forces, and especially black carbon and methane, have had a special focus in the work of the Arctic Council. And could you please elaborate on why this is so, as well as if you see any changes in this role for the future? I guess it also relates to the presentation of Mikael. So.
Yes, certainly. So multiple climate modeling studies have shown over and over again that cutting black carbon emissions and also methane emissions, so if you cut both of these air pollutants, these are very powerful actions that are available to all countries to slow the pace of Arctic warming over the next 20 to 30 years. And so this is a critical time period for avoiding climate tipping points. And so this is primarily a motivation for us to look at this time period. And reducing emissions of black carbon particulate matter from Arctic Council countries is particularly effective because these emissions directly contribute to Arctic snow and ice impurities, which are a big part of the puzzle that we're looking at as climate scientists. So, but of course, to limit Arctic warming beyond 2050, and the longer-term reductions in emissions of carbon dioxide are also critical. And we actually need to address other substances as well, not just carbon dioxide and black carbon and methane. A wider range of policy actions are required to reduce Arctic warming. Thank you.
Thank you, Knute. Karli, would you like to add in something on the question?
Well, I could first of all, can you hear me via this? Okay, yes. Hello, everyone. I'm a local now here in Glasgow. I'm Karli Kupen from the Finnish Ministry of the Environment, and I'm one of the co-leads of the assessment that we've been hearing about just now. And I'm also a negotiator in the Finnish delegation here. So happy to see so many of you here, and happy, of course, to see all the good experts we have back there in their own home offices. But anyways, yes, I could indeed just shortly comment that I fully agree what Knute pointed out. There's a specific importance from the regional point of view on black carbon actions in the high north, whereas in terms of methane, there is perhaps more room or actually crucial to have global coverage in the first place. But I think this global coverage, as Knute rightly pointed out before, applies also for the black carbon eventually. So perhaps just a short remark from my side here. Thank you.
Thank you, Karli. I guess this goes to the panel in general. I mean, what we've heard now is a lot of the results from the Arctic and how it influences the Arctic. But of course, where we are now at the COP, most of you have like a global perspective. So to what extent do you see reductions from the Arctic states' contributions on short-lived climate forces to how could that actually contribute to reach the goals stated in the Paris Agreement? Maybe Knute or Mikael, you could say something on the contribution to the global picture. And Karli.
Well, yes, thank you. I think one important point about the Arctic is, as somebody remarked already in the presentation, that it is a kind of test ground and a possibility to demonstrate that actions can be taken and the actions have results. And there is this kind of regional learning. And of course, also the Arctic observer countries are many, so it already naturally spreads in that way. But I think one should not dismiss the idea that indeed, by way of example and demonstration, it is possible to upscale and to get this broader global discussion. And that is one of the ways I see it from a policy perspective. Thank you.
Yeah. So just my perspective is, first of all, obviously black carbon is not in so to speak climate basket here, but it is a climate forcer, very much regionally oriented, and also of course acknowledged by the IPCC as an important factor. So I think it's quite good that the Arctic Council countries as a regional actors take this responsibility on moving onwards with action against black carbon. But then what comes to methane, that's obviously a very, very relevant pollutant for us all, and also part of the suite of greenhouse gases that we talk about. And perhaps I could highlight just a recent event taken up by the head of states just yesterday. We have a global methane pledge that strives for minus 30% reductions globally on anthropogenic methane emissions. And we have approximately 100 countries already joining that. And I think I haven't checked the last list of countries, but I guess almost all Arctic Council countries are also in that pledge. So I think here we can see that, because we've been discussing, of course, methane issue and methane reductions in the Arctic Council for quite a long time, and have had already the vision to reduce emissions there for a long time. But now it is good that also globally there is now action taken in this specific pollutant. Thank you.
Please, are there any comments from the rest of the panel? I just had to look at you on the screen. I hope you raise your hand if you have anything. Anyhow, I saw there was a hand raised at the among the audience here, and I do see that AMAP have kind of invaded the scene. So Jason Box, one of the co-leads of our climate report, please.
Hi. I wanted to inquire about these large wildfires that we've observed recently in Siberia, and to what extent could those overwhelm this carbon emissions discussion? These are, kind of natural or anthropogenically enhanced sources of black carbon. And what do we know about the deposition of this black carbon onto the bright surfaces? Do we have, what is the radiative effect of those fires on the cryosphere?
So I think maybe I should take that question. So it's nice to hear your voice, Jason. Great points to make. So wildfires in Siberia are part of the natural process, particularly in the boreal forests, and of course in the taiga and the steppe, as many of the grasses are fire dependent. There's no denying that these have been extreme fire years, and that they have led to this past summer being a complete season of smoke throughout much of Sakha and Yakutia. And so I think in our assessment, we did not, because we started it in 2019 and completed it during 2020, we did not necessarily think about what these extreme events would be, even though I remember clearly Knute brought up the 2017 extreme fire in British Columbia. That was such a huge fire. So we will have to consider that, because there have been pledges for deforestation, and of course that will be important in the boreal, but what are the impacts of these carbon emissions from fires will be difficult. And it is also important to note that even here in the Arctic and the boreal, the vast majority of ignitions are human caused. While our largest fires are lightning caused, the number of ignitions, number of fires are human caused. And so there is some policy and management that I think Mikhail pointed out, that we have room here for collaboration, cooperation, and innovation. As far as black carbon deposition goes, I'm going to turn it over to Carl, because I'm sure that he can explain this better without an echo.
Okay, I didn't quite catch that, but Knute maybe wants to say something on the importance of the different emission sources on deposition and as well as the climate impact. I think we know about that.
Yeah, like Jessica said, we didn't specifically look at the recent fires, which have been tremendous in terms of the emissions and also the transport. So looking at satellite pictures, you can clearly see the imprint of these fires onto higher levels of the atmosphere. So this is not just a regional phenomenon, it's really affecting hemispheric processes. So anything that's emitted from North America ends up in other places of the world in the Northern Hemisphere, and specifically to the Arctic. So the transport of these emissions to the Arctic is relatively efficient because the pollutants are at high levels in the atmosphere, and then they're transported to the Arctic, and that's where they fall onto the snow and darken the snow. And unfortunately, the science is still evolving. So we don't have any definite answers, I would say, with regard to fires. There's uncertainties associated with the emissions, and there's uncertainties associated with the chemical processing in these fire plumes, and then finally the removal processes, how these pollutants end up on the snow and on the ground. Those are leading edge science questions, and I think we're in an exciting time as scientists that we can actually study these things. And so we need, I cannot say that we need observational studies, we need modeling to really provide definite answers that are really required in this area.
Perhaps I can add one issue. I mean, we are just issuing I wonder if you mentioned it in the beginning, but we are issuing the full science report towards the end of this year, hopefully, and there are specific chapters about the observations that I remember touch upon the relatively recent episodic events that have been there on fires, and you know, it's not only forest fires. There have been some peatland fires in the Greenland that have been sort of case studied. So keep an eye on that product, and of course the AMAP team sort of. But anyways, for all, keep an eye on that to be delivered later this year. Thank you.
Thank you. Would you like to follow up the question, Jason?
Sure. So based on the reactions, my sense is that we lack the observations of black carbon deposition on bright areas across the Arctic. I know that there are a few studies but it seems like an urgent gap. It makes me think of the Mosaic expedition. They must have made these kind of measurements, or then you've got coring, stratigraphic records from cores from ice caps that could be used to reconstruct that. So it seems to provide a roadmap for quite a lot of work that needs to be done if we're going to understand what is the radiative forcing. How much more melt is there from these wildfires? Is it an open question still?
I will just note that the largest wildfires are occurring later in summer, usually late June, July, and into August. Wind transport, and I think, as Knute was saying, some of the processes that lead to the deposition are potentially less likely, and also there's just less sea ice for the black carbon to deposit on. The early season fires, the ones that we're starting to note right in April, May, when the transport to the Arctic is most likely, and the deposition on sea ice can lead to early season melt. Those fires are not forest fires. Those are human-caused fires, often in peat, in wetlands, in croplands, and in some steppe and grasslands across North America and Eurasia. And those are those are likely policy management goals that can be, there's an opportunity there for those to be reduced, to be eliminated. And I think that some of the work that Mikael was showing from the EU BCA project was trying to get at that. How do we relieve some of those early season fires? So I hope that answers part of your question, but I agree with what you said. This is a huge opportunity, and we do need to really have an idea of what the radiative forcing is from the wildfires.
Let me also come back, Jason, thanks for the question, and thanks for reminding the second part of your question, because I don't think we first touched upon that. I mean, there is some field studies that have been taken in the high Arctic, in the Pan-Arctic, on collecting the deposition of snow and assessing the black carbon content of that in the snow, as well as then looking into the source contributions, indicating a significant biomass contribution, which would then perhaps be explained by the high north wildfires. But indeed, these are individual studies, and we should have, I think, a more comprehensive pictures on a regular basis to follow up that question, and of course strive for more source contribution studies also in that respect. So I agree with you that definitely that is an area to recommend for further studies. I think we have done that in the this assessment as well as previous assessments for sure. Thank you.
Thanks. There's a question from the audience here. If you please could step up and also introduce yourself at the beginning of the question.
Good afternoon. My name is Daria Shapovalova. I'm from University of Aberdeen, and I'm very excited to be here because this is something I've been working on for years. I work on Arctic environmental governance, and I agree with you that the Arctic Council's work on black carbon and methane is a success story of the Arctic Council, not only in the scientific findings, but also from mobilizing that political consent as well. So my question as a lawyer is, what's next for the expert group? Is there any plans on following up on the implementation of recommendations in the latest report? Is there any plans of working with industries directly, especially in the oil and gas, and what's after the 2025 goal? Thank you.
I think that goes to Carla and to Mikael. So Mikael, would you like to start?
Yes, thank you. Thank you for the question. I think it's a very important point you raise, and it's an ongoing process, of course, within the expert group and the Arctic Council to really, as I said, start to dig in and evaluate the policies that have been put in place, because some have turned out to be more effective than others, and some areas, in particular, for example, the transport sector has progressed very well in reducing emissions, but then other are more difficult and require different approaches. So I certainly see that there is a need for further work in the expert group, and Carla is the best person probably to say something about the current progress, but we are working both to support the expert group more widely in the governance research, looking into these specific instruments, and in particular, I think it's important to underline, as I tried to show, that these are interacting, and put a link to what we call the roadmap of meetings that was developed in particular by Brad Matthews, which shows the complexity that it's not just one body or one set of meetings that is doing this work, but we have them all over the place, and there's a need to have this coherence between the different actions. And there I see that the Arctic Council and the observer countries can have a very significant role to play. But over to Carla on the more detailed up-to-date.
Yes, thank you very much. Thanks for the question. It is very timely, I can assure you. Well, if you think about the mandate given to us, Arctic Council countries and permanent participants, and I would say observers as well, from the ministerial in May in Reykjavik, it indeed points out towards revisiting or looking at the goal that has been put up, and as a plural, so the goals. So I think we have the mandate now, Arctic Council countries, to start this process. But Russia has just taken over the chairmanship, so we are under their chairmanship now, and the process is starting. So it is too early, of course, to say how and what kind of issues will be taken up. But the process is starting, and of course we have to, in my opinion, look at the concepts in a broader sense and keep listening more to what will come then during this course. But we have the mandate. Thank you.
So much for the question. Our next question comes from Pam Pearson, ICCI. Before Pam asks a question, I also would encourage those people out at the hubs to send a message to the technical staff if they have a question. So please, Pam.
We appreciate this focus on black carbon. I would say that especially at this COP, it is really AMAP that is carrying the entire message of black carbon. Although there is an entire methane pavilion, perhaps we want to look into a black carbon pavilion at some point in the future. I was wondering if you could speculate about the potential for any sort of interaction between, so this is more to Carle, between the Arctic Council joint commitment to the 25 to 33.33% reductions and the LRTAP Convention's revision of the Gothenburg Protocol, and whether the Arctic Council commitment might interact with that and come to a change where it perhaps adopts at least the Arctic Council's commitment as it moves forward. Thank you.
Well, thank you for the question, Pam. Again, very timely as the last one. Well, I mean, I can comment perhaps from the perspective that in the Arctic Council we are the 8 plus that discuss, but in the LRTAP we are of course a larger community. We have made the LRTAP or the Convention on the Long-Range Transport of Air Pollutants very much aware of the work of the Arctic Council, and there are many elements in that work stream as well. So as we start now revising that protocol, we have to of course revisit all these parts, but it's too early to say if there is political willingness in that forum to take on quantitative targets or something like that. At least I have not heard. I'm not the government official following that stream necessarily, but of course I'm very much informed about those talks as well. But I think the talks start and are ongoing, so we'll see. Thank you.
Maybe Ben, you would like to say something about the interaction between the different parts of the Arctic Council, like the expert group, the ACAP working group and AMAP working group, regarding how we actually work on black carbon and methane issues.
Yeah, thanks, Rolf. So because of the importance of black carbon and methane, we are not the only group under the Arctic Council working on these issues. So we, AMAP, take on kind of the broad assessment with a large focus on kind of pan-Arctic trends and future projections and implications, climate, air quality, public health. We also have a complementary working group, ACAP, that works at the project level. And so their work is very complementary, where ACAP can explore kind of on the ground projects, explore the potential of different technologies, mitigation options in different sectors like transportation, diesel vehicles, agriculture, etc. And then there is a third group under the Arctic Council, the expert group on black carbon and methane, that focuses on the policy issues at the Arctic Council level and informs the Arctic Council about any voluntary measures, commitments the Arctic Council would like to take collectively, and AMAP will continue to play the role of informing the policy questions for the Arctic Council. I think, for example, this recent global methane pledge that Carla referred to I think that would be ripe for AMAP to kind of, evaluate how that scenario would compare to the scenarios that we already looked at in this most recent AMAP assessment. So I think, given the fact that changes in these emissions, they are short-lived climate forcers, can have a near immediate impact on both the climate and the health. I think it is important to evaluate trends in emissions on a fairly frequent basis to evaluate how we're doing and where the opportunities are for further benefits.
Thank you, Ben. I just wanted to kind of turn the table a bit, because we've been talking about now the success stories when reducing emissions and so on. However, the short-lived climate forces report kind of shows the duality in this. And Susan, you said, you told us about health effects of short-lived climate forces, and one of those dualities that we've been pointing out in this report is the masking effect of sulfuric compounds versus the health effect of such compounds. How would you explain to us on how to act regarding this contradictory effects of sulfuric compounds on human health versus climate? I mean, you kind of put us in a hard choice, like choosing between climate effects and human health effects, and the numbers you presented, they were rather immense.
It's a great question. Thank you for asking that. And it is a challenging question because, yes, there are some pollutants that both warm the climate and damage human health. And those are the obvious ones to be reducing for win-win, for a societal win-win. We improve the climate and we improve public health. For those pollutants that have a contrasting effect on the climate and health, it becomes a little bit more complicated. And yet I would say that it still can be relatively straightforward. Air pollution, as I said, is the fourth leading risk factor affecting global health. We can't not address air pollution. We need to improve our air quality to protect human health. We also can't not address climate change. This is the largest challenge to public health now and in the future. And so we need to be addressing them both simultaneously. And so that means that we cannot avoid reducing sulfate. We need to reduce sulfate to improve public health. It just means that we also need to ramp up our reductions in climate warmers. So we need to be coupling any sulfate reductions with reductions in black carbon and methane and carbon dioxide. And so it points to the need for further reductions in climate warmers to be able to simultaneously protect public health and avoid warming.
Thank you, Susan, for explaining us this. And I would like now to introduce Lasse Björn from ACAP. Not only from ACAP, but he's also representative for Sami Council, so also representing some of those that kind of feel both these effects on in their everyday life and actually on the body, on both on how climate influences your work with reindeer and other livelihoods, as well as human health effects. So Lasse Björn, please, if you could say something about this and then introduce the films, the ACAP films to us afterwards.
Thank you for that. My name is Lasse Björn. I'm the Sami Council representative to the ACAP working group. I think it's two reasons for why the Sami people and why the indigenous peoples of the Arctic are interested in SLCPs. And the one is on a larger scale. These are our food systems. The forest with fires are our lands where we have reindeers. The ice that's melting is the hunting grounds for Inuits and others, people who use that for their lives. It's the food systems where we need to survive as a people, and also a food system to secure, food for the future for the whole planet. And that's why indigenous peoples are interested in these questions. I'm not a scientist, do not know all the technical stuff like from AMAP, but it's very interesting to see the assessments of this. The other part from why the Sami communities and also the rest of the indigenous peoples are interested in is because we have small local communities all over the Arctic. People are living far away from normal transport. There are lots of old technology related to diesel generators and so on. We have quite a lot of small, not the largest outputs of black carbon and SLCPs, but they are there and they are affecting our local communities. So that's why the Inuit International Association has a project on black carbon in local communities to look at the effects for the people living in the Arctic. And I think that's important to note when you're talking about all these issues, is the people living in the Arctic we are doing this for. So what are we doing? As I said, I'm working with the ACAP working group. We have projects both on the large scale. We will see a video from the APG flaring project in Russian side of the Arctic, looking at solutions and problems with APG flaring in the Russian side, and also looking at how we actually can find solutions that only helps the environment, helps the human health in the area, but also is economically suitable for the people. The other video I will talk about is the Tundra project, and it's a video about a small-scale solution, how it's for reindeer base in the Russian side of Sapmi, and how they use the new technology to remove one old diesel generator and with a windmill and new diesel generators. So, and I'm talking here about putting up windmills. And if you're from Norway or from Sapmi, you will see that's quite a conflict. Why are Sami people talking about windmills, about wind turbines? And the question is all about scale. We need energy for our needs. We need energy to remove our pollutants, our black carbon, our CO2 emissions. But we do not need larger scale for all of the Arctic. We do not need larger scale wind industry to remove, to place other industries that will remove our place in the Arctic. We have a place, we have our sustainable ways of living, and that's important for me to note, that we need clean energy for our needs, and that's why we are working with the project in the Arctic Council. So first, we will see a video on the APG flaring project, looking at solutions for larger scale solutions to stop black carbon emissions. Then we will see a video on the Tundra project. Thank you.
So if there are any other questions, still an opportunity to ask. Do we have? Okay.
Rapid climate change is taking place in the Arctic, leading to a number of adverse effects such as accelerated melting of snow and ice, ocean acidification, permafrost thawing, and increased frequency of forest fires and extreme weather events. While warming in the Arctic is above all a consequence of carbon dioxide, emissions of black carbon and methane have a strong near-term warming impact on climate. These substances are referred to as short-lived climate pollutants. They are contributing to these rapid changes in the Arctic as well as to air pollution. Associated petroleum gas, or APG, is a byproduct of oil production that contains a large amount of methane. Flaring is often used to burn off this gas, a process that is sometimes necessary for safety reasons. Unfortunately, flaring of APG is a major source of harmful emissions of short-lived climate pollutants, including black carbon. Most flaring of APG is also a waste of precious energy resources.
A significant share of the emissions of black carbon and methane stems from existing oil and gas operations in the Arctic. In response to AMAP's assessments, our working group carried out a pilot project financed by the Project Support Instrument. The project involved Russian oil and gas companies and consultants. The objective was to analyze challenges, show technological solutions to cut emissions, and study regulations that can strengthen implementation. The solutions are available, but investments are needed. Such investments will be economically sound. They will also provide benefits for the environment and positive health effects to society, in addition to economic gains for the companies. The investments will provide win-win effects. In some Arctic countries, such technologies are already applied.
There are several technologies for reducing black carbon emissions and making good use of associated petroleum gas, or APG, in the Russian Arctic.
These include capturing, processing, and using gas, for example, to supply methane to pipelines and power generation plants. The APG could also be re-injected into the reservoir or used in small gas chemical plants.
Introduction of such best available technologies could reduce emissions of short-lived climate pollutants in the Russian Arctic from 25 to 7 million tons of CO2 equivalent by 2025. The application of these technologies is currently limited due to poorly developed infrastructure in remote areas. Therefore, it is extremely important for companies to share their experience in the implementation of APG best practices in the interest of promoting opportunities for scaling up. Significant environmental and economic benefits can be achieved if best available technologies are applied.
Canada's national oil and gas methane regulations were developed through extensive consultations with subnational governments, industry, and other stakeholders. The regulations, which mandate the detection and repair of leaks and limit deliberate venting, were developed to meet our commitment to reduce methane from oil and gas by 40 to 45% by 2025. Under our recently released Strengthened Climate Plan, we will be looking to make deeper reductions from the sector beyond 2025. A more efficient oil and gas industry will keep Canada globally competitive while protecting the environment.
The pilot project to cut emissions of black carbon and methane from flaring gas implemented by ACAP in cooperation with the leading Russian oil and gas companies represents an excellent example how we can work together to get drastic results. Continued dialogue and cooperation across Arctic states to share best practices for addressing short-lived climate pollutants will help us achieve our collective goal to reduce black carbon and methane emissions and foster a cleaner, healthier, and more productive Arctic. What we need is a will and engagement of all stakeholders, governments, private sector, science, indigenous people, and other communities.
By scaling up the use of best available technologies and best environmental practices in petroleum fields, Arctic states have a clear opportunity to achieve environmental benefits by slowing down the pace of climate change in the Arctic, human health benefits by reducing exposure to pollutants in Arctic communities, and economic benefits by making use of resources that are currently going to waste.
Thank you for the video. The next video will be from the next video will be from the Tundra project. It's an example from Murmansk and Sami village, far away from a reindeer base, how they removed one diesel generator with new tools. It's an example of how we can, with new technology, both increase living conditions for the people living there, while reducing emissions, while reducing black carbon, and doing it on a scale that benefits all. Thank you.
Energy security is an essential issue for remote, off-grid communities in the Arctic, and they often rely on old diesel generators to produce electricity, depending upon costly transport of fuel through harsh conditions. The Tundra project aimed to pilot alternative, clean and reliable energy solutions in a remote Arctic community. The Tundra needed reliable electricity at their largest reindeer herding station in Polomos, an off-grid site located 70 kilometers from Lovozero village, the Russian Sami capital. Lovozero is located in a remote part of the Murmansk region of the Kola Peninsula, with a population of just over 3,000 people.
Сегодня мы находимся в самском селе Ловозеро. В Ловозеро живут люди разных национальностей, очень многих национальностей. В основном местное коренное население – это самы. Мужчины занимаются оленеводством, выпасают оленей в тундре. Женщины их, сестры, матери шьют национальную одежду для них, также занимаются рукоделием, делают вышивку из бисера.
It was time to pack our snowmobiles and meet some reindeer herders on our way to Polomos.
Стадо у нас выпасается на пастбищах, у них корм идет ягельный. Вот.
Reindeer culling at Polomos is done through the dark polar winter, so bright lighting is needed approximately 12 hours a day during the season.
В период до 2015-2016 года на лениводческой базе Полмыс использовалась обычная генераторная установка, которая заводилась исключительно по времени. То есть мы ее заводили в период с 17:00 до 12:00, ну и иногда еще с 3 часов дня и до 12:00. То есть в утреннее и ночное время электричество на данной базе отсутствовало.
A mobile power generation system with an integrated wind turbine and new diesel generator was installed in 2015, providing the reindeer herding farm with an independent electricity supply. Also, a complex set of energy-efficient measures to reduce electricity and diesel consumption at the reindeer farm were implemented. Since the integrated wind diesel power system was installed in April 2015, it has dramatically improved living and working conditions in Polmos, providing an uninterrupted and reliable supply of energy. The new system has reduced fuel costs and the harmful emissions that produce black carbon, carbon dioxide, nitrogen dioxide, and sulfur dioxide. The Tundra community is very pleased with the integrated wind diesel system. And the results of this project suggest the potential to successfully scale up energy infrastructure investments in the Arctic that are cost-effective and better for the environment.
Okay, that was the last move from ACAP. We'd like to thank you all for coming to the session. Also, thank you to the presenters as well as the audience. Those who are interested, you can find the some proposed makers on the technical report So again, thank you, and